Hi guys, today we're going to talk about some special types of systems. When you solve an equation using substitution and elimination, sometimes some weird things can happen, and we're going to talk about that today. Just some quick reminders and announcements. Don't forget to email me at bmcneely@riversidehighschool.org. It's definitely not too late to turn in late work. Don't forget, you just have to submit it. You don't need to email me, just get it handed in. Make sure that you stop now and get out a pencil and paper if you don't already have it. Make sure you're logging into your school email address. If you don't know how to log into your school email address, you're going to need to email me. Don't forget, you're going to be locked out of all these assignments if you aren't logged into your school email address. There's never a good reason to leave blanks or write IDK in an answer blank. Email me or attend office hours to get your questions answered. Don't forget that quarter 4 ends May 21st. If you're passing with a C or better and you're happy with your grade, then you're done. If not, you'll need to continue working for an additional week, so let's get these assignments handed in. Don't forget that if you have a 60% or better, you will be eligible for remediation at the end of the semester, and most of you can hit that mark just by handing in missing work. Bonus point project. We'll be offering you a bonus point project for the month of May. You can find all the information about that on Haiku. It'll be due no later than midnight on Friday, May 29th. Any struggles or celebrations today? I don't feel like I have much going on. We took a nice walk today. We've got a squirrel in our backyard that has a snow white tail. So got some weird stuff happening, I guess. All right, equations with variables on each side. So I want to start with some review. I want you to pause the video and try to solve each of these equations below on your own sheet of paper and then come back when you're done. Welcome back. You should have recognized that there were two sides, and you want to simplify each side first. So let's look just at the left-hand side. 2x minus 5x, because those are like terms on the same side. I don't do the opposite, I just do what it says. 2x minus 5x is negative 3x, and I just bring down the plus 7. These are not like terms, so I can't do anything else there. Let's look on the right-hand side. I don't have any like terms or parentheses, so I'm just going to bring these down. Now I want to look at the like terms on opposite sides. I've got like terms on opposite sides that are both negative 3x, so I do the opposite since they're on opposite sides by adding 3x to each side. The negative 3x and the positive 3x cancel. The negative 3x and the positive 3x cancel. I'm left with this weird thing that says 7 equals, sorry about my weird 6, negative 16. 7 does not equal negative 16, and the x's have all canceled out. So what that means is this is either no solution, or we could use this symbol, the circle with the line through it. For this one, you should have drawn your line down. You should have looked for your like terms. 3x minus 7x is negative 4x. We bring down the plus 9, bring down the equal sign, bring down the negative 4x minus 12. These aren't like terms, so you can't combine those. These aren't like terms. Now we start looking for like terms on opposite sides. We've got the negative 4x and the negative 4x. When they're opposites, on opposite sides, I do the opposite. So I'm going to add 4x to each side to get those together. We bring down the 9. We bring down the negative 12. The x's have all canceled out. Negative 4x and positive 4x don't make x. If I write that, that means negative 4 plus 4 is 1, which is not true. 9 does not equal negative 12. So again, my solution here is no solution, or you can write it as the circle with the line through it. All right, let's do example 3 together, and then you can try example 4 on your own. Remember, we want to simplify each side separately first. So for this one, I'm going to distribute. Negative 2 times 3x is negative 6x. Negative 2 times 4 is negative 8. These aren't like terms, so I stop there. My left-hand side is simplified. Now we're going to look at the right-hand side. I've got two like terms, and you want to be careful with your signs here. Negative 2x minus 4x is not negative 2x. If I borrow $2 from you and borrow $4 more from you, I owe you $6. So it's negative 6x minus 8. Now we're looking for like terms on opposite sides. I'm going to add 6x to each side because I do the opposite. The x's cancel, the x's cancel. I'm left with negative 8 equals negative 8. Now this is really similar to the ones we did on example 1 and 2. The x's have all canceled out, but this time the answers are the same. So that means there are infinite solutions that would make this equation work, and we can shorten that by using a laying down 8. You pause the video and try example 4 on your own now. Welcome back. You should have drawn your line down. distributed your 3, so you get negative 6x minus 3. And then for this one, 1x minus 7x is negative 6x minus 3. Now we're looking for like terms on opposite sides. We add 6x to each side because we do the opposite. The 6x's cancel, equals negative 3. These do not equal, and the x's have they do equal. Negative 3 does equal negative 3, and so we say that our solutions are infinite solutions with the laying down 8 next to it. All right, that's expected that is review, not new information. So if you're struggling with how to do these problems, you should stop here. You should email me or come to office hours and we can work on these together because the rest of the lesson is going to be a challenge for you. All right, let's remind ourselves what a system of equations is. A system of equations is just two or more equations that have the same variables. So this is a system of equations because we've got two equations, both with x's and y's. Two equations, both with x's and y's. Those are systems of equations. The solution to the system is a point where the two lines intersect. The solution can be written as an ordered pair x comma y. So when I look at your answers for the solution to a system, I should be looking for something that has parentheses with both an x and a y. All right, this is just review, okay? If you do not know how to use substitution or elimination, this is not going to be good times for you today. You need to stop here. You need to go back to Haiku and redo the lessons on substitution and elimination. Then attend an office hour with Mrs. McNeely. Did you know that I actually get paid monies to help you? So stop by an office hour. We can work together. I'm happy to help. All right, so how do we solve a system of equations? We've learned 3 ways: graphing, substitution, and elimination. This was actually a question on one of your last IPs. How many ways are there to solve a system of equations? There's 3: graphing, substitution, and elimination. You're going to have to start choosing which method is best for you. For graphing, you should really only use graphing when you're asked to graph. It's not very convenient otherwise. Substitution, you should use when one of your variables is already isolated. Like if you have y equals 2x plus 3 and y is already isolated, that would be a good equation to use with substitution. I would use elimination when one of your variables is not already isolated, like when your equations are both in standard form. So here's a review of your method. If you're going to graph, you're going to start by putting both your equations into slope-intercept form. You're going to graph the two lines and you're going to find the intersection point. To use substitution, you're going to isolate one of your variables, substitute that expression that you got when you isolated for that variable into the other equation, solve, and then substitute into either equation to find the other variable. If you're going to use elimination, you should line up your equations in standard form, multiply if necessary to create opposite coefficients, and then add down the columns to eliminate and then solve. Notice that step 4 on both substitution and elimination is the same. You're going to substitute your answer into either equation to find the other variable. For all of these, your solution at the end is an ordered pair, always. That never changes. The solution is always an ordered pair, like that. All right, so remember, last chance, stop here. You need to be able to somewhat use substitution and elimination and be familiar with the steps. All right, so remember, when we look at a system of equations, we are looking at where the lines intersect. So the ones we've been looking at up until this point are all lines that intersect at one point. So the solution is right there. There's one solution. And so this point is about, it's not perfect, so it's about 2.3 comma 2.3. I had to kind of estimate to get that solution. These are the only type that we've worked on so far. Even when we just have the equations, these all intersected in one point. But that is not always the case. Sometimes these lines do not intersect, which means there is no solution. You cannot write your answer as an ordered pair. You either write no solution or you write phi, the circle with the line through it. Or sometimes you will find that the lines perfectly overlap. If I were to draw this in class, I would put another line on top of it like that, and I would have 2 sets of arrows to show that there are actually 2 lines here. The lines perfectly overlap, which means there are infinite solutions. There are an infinite number of points where those 2 lines overlap. For our solution, we either write infinite or the laying down 8. You should right now stop and take some notes on this page for the 3 different things that can happen when you solve a system. All right, so let's talk about how we will identify a system that has no solution. So I'm going to do this one, and you're going to do the U-try. So for this one, I noticed that y is already isolated, so I'm going to use substitution. I noticed that y is already isolated. Y is the same thing as x minus 3. It's like I took $1 and gave you 4 quarters. It's the same amount of money, they just look different. So now I go to the other equation and I replace y with that expression. So I'm taking the equation y equals x plus 2. I'm replacing y with what's in the square here, so that's x minus 3 equals x plus 2. This should look a little more simple than the one we did earlier where we have equations on both sides. We don't have to simplify. Like terms are already combined. Like terms are already combined. But I have like terms on opposite sides. I have a 1x and a 1x. The opposite of a positive 1x is a negative 1x. So I'm going to subtract 1x from each side. Those cancel out. Those cancel out. I'm left with negative 3 equals 2. When one of my variables is eliminated and the two sides are not equal, then my solution is no solution. On your IP, you will have to just type out no solution. If we were in class together, you could use the shortcut, the circle with the line through it. Would you please pause the video and use this same method to try the next example? All right, you should have recognized that y was already isolated. Y is equal to x plus 7. So I'm going to go to the other equation, y equals x plus 5, and I'm going to replace y with x plus 7. I'm going to subtract 1x from each side. Those cancel out. I'm left with 7 equals 5. The x's are all gone. If I write x, that means that 1 minus 1 is 1, which is not true. The x's are eliminated. Remember, this is called elimination and substitution. It eliminates one of our variables. This becomes no solution because there is nothing that will make 7 equal to 5, and I write the circle with the line through it. Now let's look at some that have infinite solutions. I'm going to do the one on the left, you're going to do the one on the right. This time both of my equations are written in standard form, so I'm going to use elimination. I don't have any numbers that are already opposite coefficients, but I noticed that it would be pretty easy for me to find a common multiple for 1 and 2. So if I list my multiples of 1, 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4. If I list my multiples of 2, 2, 4, 6, 8, and so on. A common multiple is 2. Well, this one's already a 2, so I'm going to multiply my top equation by 2. The bottom equation stays the same. The top equation becomes 6x plus 2y equals negative 1. The bottom equation becomes negative 6x minus 2y equals 2. So I have lined my equations up in standard form. They already were. I have multiplied to get a common multiple with opposite signs. I've got a positive 2 and a negative 2, and now I'm going to add. 6 plus negative 6 is 0. 2y minus 2y is 0. What I'm left with is just 0. Not 0x, not 0y, just 0. There's nothing there. Negative 1 plus 2 is 1. Oop, I made an error on this one. Let's go back. This one should have been a negative 2. I'm sorry, because when I multiplied, I distributed, except for that one. 2 times negative 1 should have been negative 2. And negative 2 plus 2 gives me 0. So my variables have eliminated. The two sides are equal. My solution should be, not no solution, it should be infinite solutions. Infinite solutions. So I will either write out infinite solutions, or I can write the laying down 8. All right, we're going to stop the video here. While the video is stopped, you can try this problem on the right, and then you're going to want to go back to Haiku and open up part 2 of today's video. Good job.